In Andromeda, astronomers recently discovered something like a structure the size of the galaxy. Astronomers were amazed at this because even the finest telescopes on the planet failed to observe this gargantuan, ring-shaped wheatses. The subject was discovered by two amateurs with a relatively inexpensive telescope. Now, scholars are asking themselves what type of structure has been distinguished and what other structure they could have missed in the universe. The Andromeda Galaxy is no longer a thing of particular interest in astronomy. Experts say that M31, our neighboring galaxy, is very well studied and photographed and analyzed thousands of times. Andromeda is a spiral galaxy, reaching about 220,000 light-years across and containing roughly 1 trillion stars, twice the size of the Milky Way galaxy. It appears as a faint luminous patch in the night sky, an interesting phenomenon that motivated 3 amateur astronomers from the USA to capture a few exclusive images of the galaxy. To make their neighboring galaxy look special, the 3 employed different filters, appropriately colored. This unveiled a pattern that which even the leading astronomers all over the world could not understand. It had been right in front of the entire time, but this structure's idiosyncrasies prevented the ability to register it. The dimensions of the formation alone are alarming. The strange object is approximately as big as the Andromeda Galaxy. This really makes us wonder how a structure of this size could have been overlooked for so long. The answer to this question is quite simple. Newly discovered structure contained only the finest gas, the same as fine layers around Uranus and Jupiter that could be observed only with help of the advanced device. The same is true of the bizarre structure that partially surrounds the Andromeda Galaxy. The 3 discoverers utilized filter which allow only light from doubly ionized oxygen to pass through. Through this filter, the gas cloud emitted an unfamiliar blue-green light, which is not recognizable by normal people's sight but was vividly enhanced by the method employed. Following the discovery, some noted amateur astronomers contacted other professionals who in turn validated it using multiple telescopes in France, California, and New Mexico. As of now, people cannot even distinguish what this structure really is. This raises the rather important question, why such a large structure has not been noticed earlier, and this credit goes to the researchers so far. Observations with different types of telescopes in different regions of the electromagnetic spectrum, including X-ray, ultraviolet, and infrared, did not reveal this gas cloud. It was also excluded that the observed effect was the result of an error in the image processing or light influx known as stray light. The importance of this finding is immense. Many astronomers think that such structure could be a sign of initial phase of the interaction between the galactic halos of Andromeda and Milky Way, because these galaxies are known to collide in 5 billion years. However, its primary structure, origin, and form are still matters that can only be elucidated. The structure could be the first hint for the merger of Andromeda and the Milky Way, because the galactic halos, huge shells of gas, dust, and dark matter from both galaxies may already be interacting. Each is traveling toward the other at roughly 110 km per second, and their halos should merge in about 5 billion years. Unfamiliar phenomena, for instance, gravitation or shock waves might occur that will rearrange the gas distribution and thereby generate emissions like those of the structure in question. The great gaseous structure of HI embraced by this configuration could be caused by such interactions and include compression or heating of the intergalactic medium. In addition, the cloud may well have been formed by winds or currents within the galaxy which have been swelled by the approach. This discovery, therefore, proved useful in determination of how initial stages of galaxy mergers are carried out. All fake. Can the errors of scientists be all denied? The explanation that prior research studies have concluded that the previous investigations have no proof that this particular structure is an artifact clarify that there is no way technical mistakes, image processing issues, and even light could have caused the observed structure. This was verified when data obtained from different wavelength bands was compared. But what are wavelength measurements in astronomy? astronomical objects are analyzed through their electromagnetic waves of radiation. This radiation includes short-wavelength X-ray and ultraviolet light, and high-wavelength infrared or radio wave radiation. Astronomers can study different properties of a physical body, gas, dust, stars, black holes, etc., efficiently using multi-wavelength observation, since each of these bodies emits radiation, which depends on this factor. That leads to another question. What are these measurements good for? This step reveals that multi-wavelength data is very important for the description of cosmic phenomena and objects. Radio waves, such as X-rays, produced by hot gas, for instance, by shockwave sources, or around black holes or galaxy activity, is visible in them. For young, hot stars and regions of active star formation, one only has look at the UV light. Infrared light detects relatively low-energy objects such as the dust, the molecular clouds, or the optically dim galaxies. What do such measurements indicate in relation to structure? For the discovered structure near the Andromeda Galaxy, earlier observations in all these ranges of wavelengths have not reported any emissions, which makes the present discovery all the more intriguing. They would normally emit some form of infrared or UV radiation, for instance. However, given the fact that one is only visible through the blue-green light of ionized oxygen, then this gas cloud must be representative of a very unique physical phenomenon indeed. Perhaps it is a very thin one, or perhaps its composition is very different to that of other gas clouds, or maybe gas clouds of this sort are only created during specific phases of galactic interaction. They have provided scientists with many questions after the formation near the Andromeda Galaxy was discovered. Here are three possible explanations for its origin, along with an additional hypothesis that goes beyond the current framework. Hypothesis 1. A leftover object of prior interactions between galaxies. The structure may even indicate that it was formed previously during an interaction between Andromeda and another less massive galaxy. In such cases, either BIS and dust streams are ejected out of the galaxies due to these gravitational interactions, or else form huge gas clouds or bridges. Chemically, these are not the same as nearby rocks and could relate to characteristic oxygen output of the formation. Since there is a prehistory of assimilation of this galaxy with relatively small galaxies, this structure can be a part of a not fully included remnant. Hypothesis 2. A new type of cosmic nebula structure not identified before. A second solution might be that the formation is a giant emission nebula where the ionization source may have been previously unidentified. Often, the creation of containing such nebulae happens when radiation from hot stars or supernovae ionize the nearest gas to produce certain emissions. It is particularly surprising that the structure is so vast and made up of ionized oxygen. This might be evidence of the fact that the structure was shaped by some supermassive event, such as an old star formation zone or an active galactic nucleus. Hypothesis 3. An intergalactic gas cloud. Still, it could not be a part of Andromeda Galaxy at all, but be a massive intergalactic gas cloud that has been pulled towards Andromeda due to gravitation. The clouds could be part of the original phase of the universe formation, galaxies, and cooled galaxy clusters. Its isolation and makeup could mean that currents in space have brought it closer to Andromeda. Hypothesis 4. A sign of dark matter and other processes of their kind. A rather bold speculation would be that the form of the structure hints at contact with dark matter or other rather non-mainstream physical phenomena. Perhaps dark matter came and affected the formation, or compressed the gas that formed it to ionization. This idea could explain why the object was so difficult to detect and displays no signs in other wave bands. This newly found structure around and in the vicinity of Andromeda is a fine example of how much of space is still waiting to be explored, even in our local neighborhood of the universe. The fact that this huge formation has remained unnoticed, although over the last decades has been scanned by the most advanced telescopes, causes elemental questions regarding how many aspects of the real structure and nature of the universe have remained unknown so far. The significance of the discovery. This structure could mean that the cosmic web of the universe, consisting of vast gas clouds, filament-like structures, and halos which are part of the extended universe, are still a largely uncharted territory. Though these Gale structures are not so familiar, they are very important in the scalability and evolution of galaxies. That is, supplying galaxies with gas for the formation of stars and through gravitational and streaming, affecting the evolution of galaxies. This research creates the impression that many other formations similar to the formation discovered here, and perhaps larger or more complex, are likely to still exist and yet cannot be observed through conventional techniques. This may imply absence of knowledge in some dynamics of galaxy interactions, star formation, and the general evolution of the cosmos. What else could be hiding? Undiscovered intergalactic gas clouds. A large number of the giant gas formations which make up the filaments of the universe are not charted. They run between the galaxy clusters and might harbor the baryons that astronomers are seeking to complete the mass of the universe. A type of dust clouds or nebulas that are obscured or completely invisible in certain part of the electromagnetic spectrum could mean undiscovered region of star formation. Dark matter and gravitational lensing. This discovery also means that DM structures, which dominate, could influence gas clouds and their dynamics and unveil interactions. How can scientists come across such structures? Further enhance the usage of multi-wavelength functionality. Special filters are important for this kind of discovery as practiced in this work. Following telescopes can isolate parts of wavelengths that have been gathered to this point. Involve amateur astronomy. Hobbyists so prove that the democratization of astronomy and the use of non-conventional methods can unleash possibilities. AI and new image processing algorithms may reveal fine structures in the current data that astronomers did not pay much attention to. The implications for research. The discovery means that our models of the universe must be kept evolving all the time. This, in turn, indicates that some key elements in the picture that explains formation of galaxies and cosmic structures and matter interrelations are still murky. Some of the findings that scientists make today mean that people may begin to see space in a completely different way.